Another topic we should mention is that of stage separation. Because of the multi-component nature of the produced hydrocarbon fluid, the higher the pressure at which the initial separation takes place, the more liquid will be obtained in the separator. This liquid contains some light components which vaporize in the stock tank downstream of the separator. If the pressure for initial separation is too high, too many light components will stay in the liquid phase at the separator and be lost to the gas phase at the tank. Furthermore, a high separator pressure will also decrease the well's productivity. If the pressure is too low, not as many of these light components will be stabilized into the liquid at the separator, and they will likewise be lost to the gas phase. Here we see a diagram which shows a stage separation process. The liquid is first flashed at an initial pressure and then flashed at successively lower pressures 1 or 2 times before entering the stock tank.
Because of the multi-component nature of the produced fluid, it can be shown by flash calculations that the more stages of separation after the initial separation, the more light components will be stabilized into the liquid phase. In addition, the compressor horsepower required is also reduced as some of the gas is captured at a higher pressure than would otherwise have occurred. For each facility, there is an optimum number of stages, and the choice of separator operating pressures in a multi-stage system is large. For large facilities, many options should be investigated before a final choice is made. For facilities handling less than 50,000 barrels per day, or in SI units 8,000 cubic meters per day, there are some practical constraints which can help limit the options to be investigated.
A minimum pressure for the lowest pressure stage would be in the 25 to 50 psig, or 170 to 350 kilopascal range. This pressure will probably be needed to allow the oil to be dumped to a treater or tank, and the water to be dumped to the water treating system. The higher the operating pressure, the smaller the compressor which will be needed to compress the flashed gas to sails. Compressor horsepower requirements are a function of the absolute discharge pressure divided by the absolute suction pressure. Increasing the low-pressure separator pressure reduces the horsepower required to compress the gas obtained off the low-pressure separator. However, it may also add back pressure to wells, restricting their flow, and it may allow more gas to be vented to the atmosphere at the tank. Typically, an operating pressure of between 50 to 100 psig, or 350 to 700 kilopascals, will be optimum.
Another constraint is an obvious one. The operating pressure of the highest pressure separator need not be higher than the gas sales line pressure required for the gas to enter the sales line.
In choosing the operating pressures of the intermediate stages, it is useful to keep in mind that the gas from these stages must also be compressed. Normally this would be done in a multi-stage compressor. The most efficient compressor sizing will be with a constant compressor ratio per stage, so this fact should be considered when choosing the intermediate separator pressures.